The next time you're in a project meeting and the energy modeler is confidently predicting energy performance and building performance and energy costs, remember three things. One, energy modeling is a mixture of science and art. The person doing this modeling really needs to be a building design engineer and an experienced one at that, or they're just a software jockey. Two, energy modeling assumes all MEP and facade systems are installed and performed impeccably. This is certainly not my lived experience. And number three, energy modeling assumes optimum operating control set points are determined and set. Plus, the control system has been tuned during early occupancy. Again, this is most definitely not my lived experience in any way. The dirty secret is that most critical energy consuming systems, such as ventilating systems, VAV systems, heating, cooling, they rely on a single $250 device, such as a pressure sensor or temperature sensor. These devices have to be installed in the correct location, correctly calibrated, and the optimum set point empirically determined via field testing, aka commissioning. These devices are single points of effectiveness and also single points of failure. So if you take a VAV system, that whole system and its performance and its energy consumption is really determined by several things, but one of the biggest factors is the correct location of the static pressure sensor and its derived optimum set point during commissioning. If you set it too high, the system will be overpressurized, it will use too much pressure. If you set it too low, the boxes won't be floating and operating properly. So there is a sweet spot that can only be determined via field testing. And if that thing fails, then the system's not going to be working at all as designed, and certainly not as the predicted energy model. So from an effectiveness and a failure point, that matters. And it's the same with a variable volume hydronic heating or cooling system as well. They all come down to a differential pressure sensor and a distribution pipework that needs to be set absolutely correctly via empirical testing. Complexity is a reality in building design and in construction and in operation. There are no plug-and-play systems for large buildings. This is not like sticking a DX unit on the wall, split system on the wall. These buildings are complex and they need correct setting to work and commissioning. Also, most existing buildings have high energy costs, not because they need new chillers or they need new equipment, mostly because the key systems are not controlling optimally with empirically derived control system set points. And everybody goes, all the facilities managers want to build a budget and buy a new chiller and get a new efficient chiller with a new chiller control system, but really it's about the whole system being set up properly and commissioned properly. You could probably get rid of half of these big retrofits if systems were set up properly and managed properly. So what are the takeaways here? One, be skeptical of energy modeling reports. Energy modelers are good and they have their place, and there are some good ones out there. But there are also a lot of software jockeys out there. You know, junk in equals junk out. If you don't understand the inputs you're putting in and how you're reading that report and how buildings work, the energy model is a bit of a factotum. It's not really useful. Two, make sure building systems and their controls are commissioned thoroughly. There is no shortcuts to this. It is a long, complex process that requires experienced people to set the controls up, commission them, and set the systems up and commission them. And number three, do not assume you need a massive retrofit to lower energy bills. Consider just recommissioning your system and making sure all the control points are optimal. That's it. Could save a lot of money here.